Okay, yesterday night we welded the stuff, the blocks, the jaws, and then I attempted to heat treat them. And in my rush, in my non-thinking, I remembered you can't heat treat welding rod because it's not a heat treating type metal, I guess. Unlike the base metal, which is 4130, which is heat treatable because of the carbon content, I guess. So that means that even if I did get them cherry red, which I actually never managed to, they would never have, the area that I welded would never have gotten hard enough to do anything. It would probably have been actually softer, maybe, than the 4130 annealed. I'm not too sure. So a lot of people messaged me and they're like, "You're kind of stupid." Nobody said that, but some people probably wish they could say that. And they were like, "Well, you can just weld drill bits to it or dowel pins." And dowel pins, I was like, "I'm gonna go with dowel pins." And then people were like, "Dowel pins are usually case hardened, not through hardened, so that wouldn't have worked." I was like, "Okay, well, I'm gonna do drill bits." So obviously, a high-speed drill bit is very hard on purpose. I don't know what like Rockwell level C a drill bit is, but it's probably 50 plus at least, I would guess. So that would be harder than this 4130 that's annealed. So I was like thinking that, well, we could just, I'll just cut a pocket into the front of the jaws, and then I'll just weld the drill bit to the jaws, and then we'll machine the drill bit into the shape we need. And then I was like, well, I'm going to Google if somebody else has done this, and of course somebody else has done this. So Jody Collier, he makes welding videos, like welding tips and tricks. He's like, he just takes the drill bit and uses it as the TIG filler rod, which is that's a lot easier. So what I'm going to do is take these drill bits that I have, and I have a ton of these, and this is going to be small enough, and I'm actually just going to weld the bead with this as opposed to doing what I just said, which is going to be way more complicated. Probably not turn out that great. And then we'll machine the then hardened weld puddle, which will have been filled in with drill bit. So yeah, we're gonna see how this works. This is a good learning experience, I guess, if you ever needed to emergency hard face something. Let's do it. Okay, those got welded up, and now we're gonna machine them again. But I'm thinking these are gonna go good. When they cool down, I'll test them with a file and see if it's actually harder up front. All right, let's see if this is actually harder. I'm actually really curious. So we got ourselves a nice dirty file with a nice bend in it. Here's the back. Seems to cut pretty easy. Oh yes, that is definitely way harder. Yep, it glides right along the weld. Cool. This is cool. Cool stuff. Okay, to machining. Alright, not too bad. I do need to add some filler on these corners here, but other than that, turned out pretty good. Alright, we did it. It only took me like 3 hours, and I had to weld a bunch more because I kept forgetting that the blob of material had to be both tall enough and long enough to be fully machined, so I kept machining it, and like corners and stuff were missing. So that was fun, but here they are. So I'm going to reinstall them and get back to work. Okay, here's the going plan. So I tried a bunch of times to like align the square that was produced with this, and I got it pretty close, but it's not close enough. So what I'm going to do is I'm actually going to cut a square with the live tool, and then I'm going to align the jaw up with one of the faces of the square, which will be exactly like the faces of the square spacer, only it's a little bit bigger, and that'll allow me to get like some measuring tools or something. Just it'll be a lot easier to visualize or see something that's this big, a square, over the tiny 1/8 size squares. So I'm going to cut this, and hopefully this works. Okay, that turned out pretty good. I'm going to come in and do a finished contour pass because it's like oversized by 7th thou on both sides. So I figure, yeah, just come in and do a nice little cleanup pass. That might have been a little oversized, or undersized. That seemed like a lot more than 5 thou. Yeah, it was supposed to be 533 or 5 something. See if I can hold you guys with one hand. So here is the one side. Not bad, 525. So, and here's the other side. So you can see it's pretty, it cuts pretty accurately, which is very surprising, honestly. I don't know why I'd ever doubt the old Korean iron, but yeah, so I'm pretty impressed with how squares come out on this thing. Okay, this should be good enough for what I need it for, so moving on. Alright, I know what someone's gonna say, but let me tell you, this is all I could think of in the moment that I'm standing here. So, obviously the goal is to align this square with our female square in here. And so what I ended up doing was I took this gauge block and I stuck it on our flat of our square. You're gonna love this, I know it. Like this, right? Right? And then I just aligned the subspindle jaw with the side of this. And that's what I did. So, as you can see, they're very lined up. Sorry, this is really, really, really hard to do with not 3 hands. So, that's lined up, and then I just felt across here until the gap felt the same. Yep. What can I say? I am a machinist. Yeah, I don't have a degree in this. So yeah, that's what I did. I slapped this against this and lined the two up. If you think that's a terrible idea, well, unfortunately for you, you're in the future, and I'm here in the past. So I'm gonna roll with it. It ended up being 346 degrees, so that's 360 minus 346, 14 degrees? Yeah, 14 degrees difference. So anyways, I'm gonna punch that into the program and see if we can get it to line up now. Alright guys, here we go, we're gonna try it. I mean, visually it still looks kind of off, but I mean, my proven method, I mean, what could go wrong, you know? Like, eyeballing it, that always works. Alright, when I hit this go button, we're pretty much, we're in for the ride. I don't know if you... I don't know if you saw anything. It transferred. I didn't notice it moved too much, so it might be good. Focus. Okay, you're not gonna focus. Kind of hard to tell. But I think it's actually square in there, which is pretty good, I think. So yeah. Alright, we're going to try machining the backside. I need a new battery. Okay, this is kind of scary because, so the jaws that I made, they're steel, obviously, and they're, you know, spinning. So the factory jaws have these teeth on them. These are not the factory jaws, but see the marks that were left? Why are you not focused? See those marks? So the factory chuck has these, you know, they're jaws, so they link up to each other. Well, these don't, because I don't know what degree the wedges are or whatever, so I just had to tighten them really tight. So what's scary about this is I'm going to open the door, and the chuck's going to spin right in front of my face. So if in a world of looseness, the chuck jaws decided to come off, it would actually probably do some serious damage to my forehead if they came out, because it's spinning at 1,000 RPM or 1,500 RPM. I don't know if you want to do the math on that, but they probably weigh like a quarter of a pound at least by themselves. So yeah, that would kind of hurt. So I'm going to be very careful. Yes, danger. Ah, yes. And we're going to do this very slowly. Another thing is, if the tool was to hit the jaw and then knock them out, that would be scary too. Yes, that's very close. I'm just going to hide back here. Probably took this a lot slower. The last time I did this, it did hit the jaws, but it didn't, like, you know, destroy anything. It's kind of hard to tell where we're going. Wait a minute. I just noticed something. Yes, the sub spindle's turning the wrong way. Yes, that'll leave a nice finish. Huh, that's weird. Okay, let's try this again. This is not the first time I did that, and I could have sworn I corrected it, but anyways. It's super scary looking. Alright, I'm gonna hold my arm, like, out so you guys can see, but I can't really see what's going on. Scared me. Alright, so the last thing it has to do, well, I still need to figure out this facing distance, because obviously, if you look, if you could see, it doesn't completely cut it all the way off. See, it's not exactly a hole. So now what it's going to do, it's going to retract, and then it's going to switch over to the backside chamfer drill, spot drill, and then it'll chamfer that, and then it'll drop it into the parts catcher. And I hear the mill making weird noise, so I gotta go look at that. So you have to send this sub spindle all the way back to its reference, calling a reference a command and not just like a home command, for it to actually, the machine to know that the B-axis is back to its home, which is super weird. So that's why I have to send it all the way back and then do a tool change. Otherwise, you can't actually tool change if the sub spindle is close. The turret will actually hit it, so that's always a good time. So like I said, we're going to chamfer with the spot drill. Hopefully. You can see how close the turret gets. Make sure we move X out of the way first, and then we move the B-axis. There's my 3D printed bin thing. And it fell in the wrong one. But that's okay, I guess. And it's done. Where is it? Where is my square spacer? Oh, there it is. Do you see it? It's right here. Oh, right here. Yep, that's how tiny these things are. Alright, very dirty. Looks like we got a crushed square spacer, so that's good. So obviously the jaws crushed it a little bit, but I mean, that could have been caused by anything, you know. Definitely not my alignment. That's what I was talking about on the back side of it not being faced. See, it's just not big enough compared to the front. It's supposed to be that wide. So it's supposed to put a nice chamfer on there, so obviously getting screws into it is easy. But yeah, so that's what I've been attempting to do for the last couple weeks. It seems like, I wanted to say days, but it's definitely been weeks at this point. So yeah, it's complicated, I guess, to make really tiny square parts on a lathe. So yeah, this is the end of the video, and yeah, I don't want to show you guys me getting a done one because it might be another couple weeks, so you can see where my head's at with the lathe, but it is making parts sort of operator's discretion at this point, and not mechanical discretion. So yeah, anyways, if you like the video, you know what to do, and I will catch you on the next one. Thanks for watching.